Okay, this is going to be the final section in Chapter 5, Section 4.4, Section 5.4. We're going to be studying elastic forces. So when forces act on a solid object, the object usually deforms. In some cases, such as a stretched or compressed string, the amount that the object is deformed, delta L, is approximately proportional to the magnitude of the applied force. So a stretched or compressed spring produces a force whose magnitude is given by Hooke's law, where the spring force is equal to some constant K times the deformation, or the delta L. So you can see here, this is our equilibrium position. Delta L is equal to 0, but if you go on either side of that, if it's moved out or if it's moved in, you can see the compression of the spring here. You can see as it's stretched out here, the spring is going to exert a force whose magnitude is approximately proportional to that displacement. So, in this particular case, when x is equal to 0, the spring is neither stretched nor compressed. So it's there and no force is really applied. But when the object is moved a distance x to the right, then the spring is stretched by an amount x. It then exerts a force with magnitude F on the object and is equal and opposite on the anchor point. So when the string is stretched further, when the spring is stretched further, the greater forces are required. So for many common materials, such as steel coil springs, experiments show that stretching the spring by an amount twice or 2 times requires forces with magnitude 2 times that force. In other words, the magnitude of the force required is directly proportional to the amount of stretch. So you can see here we stretched out x, we have a certain force that goes along with that. If we do it twice that, then we have twice that particular force. And the spring force points in the opposite direction of the displacement. So again, a K is going to have units of newtons over meter, which since you're multiplying that by the displacement to get the force, that would make sense, and force is measured in newtons. Delta L is, of course, going to be in meters. The K is going to measure the stiffness of the spring. The spring always pushes back towards its equilibrium position when compressed and pulls back towards the equilibrium position when stretched. So again, we've got some exercises here. It'll be very good for you to go through. And that is the end of Chapter 5.